now move on to discussion and proof of theorem 1016. This theorem reads that if we have two secant segments that share the same endpoint outside a circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. So that, for example, if we start with a circle such as this, and we have two secant segments, let's say coming from a common point E. One going like this, one going like this. So we have the two secant segments are intersecting the circle, let's say in points A and C and points B and D. Then the theorem states the measure of EA, which is the external part of one of the secants, times the entire secant segment times EB is equal to EC, which is the external part of the other secant, times that entire secant segment ED. So in other words, AE times EB equals EC times ED. This theorem is also proven using similar triangles. And in order to identify our similar triangles, we need to draw in chord CB and chord AD. By doing so, we now create two similar triangles, namely triangle ECB, which is now similar to triangle EAD. Okay, and what we can do is we can put in similar angle. We can show that those two angles are the same because they both intercept the same arc AC. We also know that, of course, angle E equals to itself, and therefore we've proven angle, and the third angle follows by the sum of angles in a triangle equals 180. So now we've proven these two triangles are similar, and now that we know they're similar, all we have to do is we have to find the appropriate ratio of their sides. And we know that in triangle ECB we have side EC will correspond to the similar side in the other triangle of EA, and we know that EC in the triangle ECB, we also have EB, which will correspond to ED. And by simply taking this ratio and cross multiplying, we get EC times ED is equal to EA times EB. And if we look at that formula and the formula we needed to prove, they are identical. We've just switched the right and the left sides of them and perhaps called the segment in a slightly different way. But we have basically proven the theorem. So that proves theorem 1016.